Hello everybody, here to help you with some of the math assignment that we have going on this week. Question number 1 says, which rule best describes the relationship shown in the function table below? So these are our numbers here, and this is the output, right? So all we have to figure out is, what's our relationship between 1 and 3? Well, I can say 1 plus 2 equals 3, right? I'm just adding 2. Well, let's see if that's true for 2. If I put 2 plus 2, I would get 4, right? That's not the same as this. So I got to figure out how else can I get to 1? 1 times 3 would be 3, right? And it's 2 times 3, 6? Yeah. It's 3 times 3, 9? Yeah. It's 4 times 3, 12? Yeah. So it looks like I figured out what my answer is, right? It would just be multiplying by 3. That's how we're doing. Just checking to see what, right? Because I multiplied by 3 here, which means I'm multiplying by 3 here and here. And that's how we got our answer for number 1. All right, number 2 says Market needs to earn a grade higher than 88 on his final quiz in order to have an A average. Which inequality best represents this situation? So which one of these, if G was the grade he needs to earn, which one of these is higher than 88? So let's think, what's the number that's higher than 88, or in other words, more than 88, right? Because higher means like a bigger number than 88. So in our heads, can you guys think of a number that's bigger than 88? Sure, let's say 89, right? Or 90. And then think, if I have 90 here, does it mean 90 is greater than or equal to 88? Is that true? No, right? And what we're trying to do is, which inequality best represents this situation? So it needs to be higher than 88. It can't be 88, because over here it says he needs to earn a grade that's higher than 88. So if he gets to 88, he doesn't get the A average. So it has to be a number that's higher than 88. So which one of these would signify that? That's number 2. All right, I'm skipping all the way down to number 4. What is the least common multiple of 8 and 14? Well, least common multiple, that's something we've learned, right? We've learned about LCM. So what we do with LCMs is we can either skip count, right? I can say 8, 16, 24, 32, 40, and keep going until I get to a number that matches. Or I can do the cake method, which is the one I prefer and the one I'm going to work out for you guys. So I'm going to put 8 and then 14, right, on the same line. And then I'm going to think, what number goes into both of these? So I'm going to draw my first layer of cake. Now I can divide both these numbers by, let's say, 2, right? So if I divide them both by 2, 8 divided by 2 equals 4. 14 divided by 2 equals 7. Now I have a prime number here, right? 7's prime. I could only divide it by 1 and 7. And there's only numbers that divide into 4 are 1, 4, or 2 and 2, right? And those don't go into 7. So this is my number here. So what I'm going to do is I'm going to take all these numbers and multiply them together. And I'll have my answer, right? So I have 2 times 4, 2 times 4 times 7. And that's going to give you my answer. I know 2 times 4 is 8. Now 8 times 7 equals 56. And there's my answer. Letter A, right? All right, that's number 4. Now, if this was asking for the GCF, greatest common factor, I would just take this left side, right? I wouldn't have to do all this. LCM, you make that L shape. This kind of looks like an L, right? Like a blocked L. Now, if it's GCF, I would just take the 2, and that would be my answer. But we're looking for LCM on this one. All right, number 5 says, what is the volume of the rectangular prism shown below? Now, this looks tricky because we see this shape, and we're like, ooh, man, I don't want to mess with all this. But it's not that bad, guys, because it's just asking us for the volume, right? And if you guys remember our formula, check your notes if you don't, or I'm going to write right here, volume equals length times width, which length times width times height, right? So there's 3 things I'm multiplying. And look at you. We have 3 numbers here, right? We have, we have 12, right? We have 3, and we have 5. So all you have to do is take those 3 numbers and multiply them together. Because this is our length, 12. This is our width, 3. And our height is 5. So 12 times 3 times 5, and you'll have your answer. Now remember, whenever you're multiplying those 3 units together, you're going to get cubed, right? Centimeters cubed to the 3rd power. So all these have cubed. If one of them was squared right off the bat, you'd be like, nope, that's not my answer. But all of them do have cubed. So multiply those three numbers together, and you will have your answer for this number 5. All right, 6 says, the list below shows the number of books read by students in Abram's class over the summer. What is the mode, right? I'm going to put a box around that, that's the important word here. Mode of the data. Now think of mode. Remember we learned about mean, median, mode? Mode is the one who has an MO, which stands for most often. So which number shows up the most often? It's hard to do it like this. I mean, I could probably guess what it is. No, maybe not. Oh yeah, I think I see what it is. But it's hard to tell, right? This way. So what you're going to do is put these in order first. And then you can go from there to determine whether it, let me see here. So we have 3, right? And then 3. So I'm going to go here and I'm going to cross off the ones I used. Boom and boom. Or, you know what? I like underlining it. So I know I used it and I didn't have to cross it off. Okay. So I have 3, 3. There's no more 3s, right? So I'm going to my next number. 4, 4. There's this one and there's this one. 4, 4. So there's 4 4s. And then I'm going to go back and I'm going to cross them off. 1, 2, 3, 4. Did I miss any? No. So then I'm going to do the next one. I have 5, right? That's the next number in order. I have 1, 2 5s. Okay. So that's what we're doing here. We're just putting our data in order and then crossing them off so we know we use them. Next I have 6. There's only one 6. Okay, I'm going to do 2 at a time here. So I have 6 and then I have 2 7s, right? So I have 1 6 and 2 7s. So that's 1 6, 2 7s. I have 8, 8, 10, 12, and then I'm done, right? So I can go 8, 8. Let me cross those off. That was 8 and 8. And I mean, you guys are getting it now. So now we have to figure out which number shows up the most times, the most often. Well, I have 4 4s, right? And nothing else even comes close. The rest of them only have 2. So that means these 4 4s are my answer. And I'm just going to say 4. So 4 books is my answer, which is letter A. So remember, it's easy to do mode. All you have to do is count. It's one of the easiest things you can do. That was number 6. All right. There are 65 people watching a movie at a theater. If 40% of the customers purchase refreshments for the movie, how many customers purchase refreshments? So, one way to think about this, let's say there's 65 people and half of them purchase refreshments. Well, then I would just know that half of 65 is what, 32-ish, 32 and a half. So my number has to be less than 32 and a half, right? Because 40% is less than 50%. So I already know that, look at, this is off, this is off, this is off. So my answer has to be A. That's a quick way of doing it. That's me rationalizing this question in my head. Now the way we've taught you guys to do this is you're gonna do 65, and then you're gonna multiply 40%. Now I can't multiply 40%, right? I can't just do it like this. I have to say 65 times and turn this into a decimal. Well, on a whole number, we know our decimal is after. Oops, not a decimal. It's after, right? Our whole number, and we're converting a percent into a decimal. We're just moving it over 2 times. To the left, right? To the left, to the left. All your stuff in the box to the left. So I'm moving my decimal over here. So this now becomes 0.40. And now you guys can work that out. What's 65 times 0.4? You guys should get, if you're using a calculator, so let me do that. 65 times 0.4. Oops, it's not 4. Times 0.4. And 0.40 is the same as 0.4, right? And that's going to equal 26. And look at, isn't that what I guessed before even doing any actual math, right? Just by rationalizing and be like, hey, wait a minute. So there's your answer. This is going to equal 26. That's number 8. All right, number 9 says Adeline is wrapping a gift for her mother in a box with the dimensions shown. So we're doing a gift box. We're not going to do volume like on the other question, because we don't need when you're wrapping paper, you don't fill up the inside of wrapping paper too, right? We just need to wrap the outside of the box. We don't fill up the box with wrapping paper. It doesn't make sense, right? So what's the minimum amount of wrapping paper that Adeline will need to completely cover the gift box? So that means I know how to figure out, let's say, this front side, right? And actually, you know what? Let me make my lines darker so I can cut in here. 1 second. So this question is asking us to find the area of, like, let's just say this front side, right? And then this side, and then the back side, and the top side, right? But luckily, since this is a rectangular prism or a box, this front is the same as the back, right? So, and I'm talking about these colors right here. Let me see if I can make it easy for you guys. Let me try this. I wonder what it looks like. Okay, that didn't work very well. But this is my front side, right? If I have this whole box filled with color, and then the back too, right? It would just be this side and this side, right? That would be the back. You see the orange is on the back and the orange is on the front. I don't know if that makes sense for you guys the way I did it that way. You know, let me outline it with a different color here. So this is my front side, right? And this would be the back side, right? And so those are the same sizes. And I know that this is 10 right here. And to figure out my height, I don't have it. It's not 6, but I know this side is 8. That means this side is 8. So I'm going to say, boom, 8. So now 10 times 8 equals 80. Then that's the front. And also the back, right? Because the front and the back are the same. And guess what? Side 1 and side 2 are the same too. And then the top and the bottom are going to be the same. And then we're going to add them all together afterwards. So I know that this is 80 and this is 80. Now I have to do this side. So let me paint a different color for you guys. I'm going to do this side that has 6, right? Which is the same as this. I'm working on this little side right here, the side of the box. So now I have 6 times 8, right? And that would be 48. And I would do 48 here as well. And now I have to do the top and bottom. So that means I'm going to change my color to, let's say, blue. Now my blue, this is my top, right? This is one side and this is the other side, which is the same as this. Now I don't have any numbers up here, but I do know that if this is 6, that means this is 6, right? And if this is 10 right here, that means this is 10. So then I know that 10 times 6 would be my area of this little shaded part right here, right? All of this. If I shade all that in, it would be 60. So now I can add all these bad boys together. I would say 60 plus 60 plus 48 plus 48 plus 80 plus 80. And whatever it equals is my answer. So I know that took a little bit of work and we're not big fans of that problem, but yeah, you're going to add all these numbers together. You'll get your answer. All right. I like it. Taking another shortcut, I could say, when I add all these together, I know 0 plus 0 plus 0 plus 0 is 0. And 8 plus 8 is 16. And look at that. 16, which means I bring my 1 up here. And look at, there's only one answer that ends in 6, right? So I know it's going to be this answer. Without even finishing my problem, I know this is it. But go ahead and finish it to make sure you guys that we're right. Look at 6 plus 4 is 10. 6 plus 4 is 10. That means 20. And then 8 plus 8 is 16. So 20 plus 16 is 36. Plus the 1 is 37. Boom, 376. That's my answer. That's how I'm rationalizing. I'm trying to make you guys kind of see how I'm thinking. To make, hopefully, once you have like a good number sense, like a lot of this stuff, you can just like, oh, boom, I figured it out without even finishing it. Although I do recommend finishing it to double check your work, like I just did. All right, so that is our answer for number 9. Let's do one more. All right, number 10 says a ratio table shows the number of miles Karen can drive for 1, 2, 3, and 4 gallons of gasoline. So for 1 gallon, they can drive 30 miles. For 4 gallons, she can drive 120 miles. So now it says how far would she be able to go or drive on 8 gallons of gas? So all we really need to do here is extend our table. So let's say we have a table here now, right? My table's just a little bit bigger. And we're saying that she's going to have 8 gallons, right? Now we have to figure out, well, what is the ratio to get from 1 to 30? What am I doing? I'm not adding 29, right? Because if I do 2 plus 29, I would get 31. That's not what 60 is. So I would say I have to times it by 30, right? And if I do 2 times 30, I would get 60. And 3 times 30 equals 90. 4 times 30 equals 120. So then over here, I'm going to have to say 8 times 30, and I would have my answer. There you go. That's how we do number 10. Whatever 8 times 30 is.